right, the next thing that we're going to look at in section 2.4 is we are going to look at something, a pair of two different statements that we're going to refer to as DeMorgan's laws. Okay. DeMorgan's laws for sets are a pair of related theorems used in set theory, logic, and other branches of mathematics that transform statements and formulas into alternative and or more convenient forms. So what we see here is we see one side has parentheses, one side doesn't, and then we see kind of the difference between our intersections and union symbols, and we'll talk a little bit more about these on the next page. But these two laws are two different sets that are equal, and depending on what type of problem we're doing, it may be to our benefit to use one rather than the other. Right. So we're going to verify these, and what we're going to do is we're going to use our Venn diagrams, and we're going to kind of take a look at the different regions that are being discussed in order to come up with our conclusion. So this is an example of deductive reasoning. So it begins with a general statement and works to a specific conclusion. Okay. So we're asked to use the Venn diagrams below to verify DeMorgan's laws. Right. Our first statement here, A intersect B inside parentheses with a complement outside is equal to A complement union B complement. Right. So one way we kind of see these referred to sometimes, we might see these referred to in words. If we want to write out this law in words, we're going to say the complement of the intersection is the union of the complements. Right, so notice if we compare one side to the other, we have an intersection sign versus a union sign, and then we have complements on, again, parentheses rather than just individual sets. So first we're going to find what's on the left side of our equal sign, our A intersect B complement. Right, so to do that, we're going to kind of work through this in steps. So these little boxes have our steps written out for us. So A intersect B is set 2. Right? Or excuse me, region 2. Right? It's the portion that's in the overlapping areas. Now, if we take the complement of that, well, then we don't want region 2. We want regions 1, 3, and 4. All right. Now we're going to look at A complement union B complement. So A complement is anything that is outside of set A. So 1 and 2 are inside A, so regions 3 and 4 are outside of A. B complement is anything outside of B. Well, 2 and 3 are in regions 2 and 3 are in set B, so regions 1 and 4 are outside. All right, so we want anything that's listed at all since we're thinking union. So we have 1, we have 3, and we have 4 listed in both of our sets. And if we compare this last line in these two different little tables here, we should notice that these indeed are equal. Okay? So the complement of the intersection is the union of the complements. So that's our first DeMorgan's law. Okay? Now we're going to look at our other law. Here, again, kind of a similar idea. We see parentheses on one side. We don't on the other. We see the going back and forth between the unions and the intersections. So again, we could write this one out in words as well. So we're going to say the complement of the union is the intersection of the complements. So let's start by listing out some of this set, these corresponding regions to these sets. All right, so on the left side, A union B. Right, A union B is anything that's in set A or B. So that's going to include region 1, region 2, and region 3. Now, if we want the complement of that, well, we don't want anything that's inside our circles. We want what's left outside of our circle. Outside of our circle is region 4. All right. On the other side, we're going to start by listing out our complements. All right, so our complement of A, remember anything outside of A is set 3 and 4. Our complement of B is going to be regions 1 and 4. Right, same thing that we saw in our previous example. Right, now instead of taking the unions of these, we want the intersection of these. Well, region 4 is the only thing that appears in both. Right, so again, if we compare what we have left in our table, we have region 4. Right, so the complement of the union is the intersection of the complements.